Gosh, Pocket Ronnie made me enjoy eating triangles. So welcome back.
Alright, we're going to be talking about ratios. The word ratio is just a fancy word for fractions. So anytime you're dealing with ratios, you're going to be dealing with fractions. So we're looking at 16A number 5. It says that there's a math class. I'd like to say it's Mrs. Knoll's math class. Anyway, has 24 students. Ratio of reading, the students who like reading the best to like math the best is 3 to 5. How many like math the best? So one of the things that you need to do is you need to, on all of these problems, you need to look at what is given and what is the question asking. Okay? So in our problem, it says that students who like reading the best to math the best is 3 to 5. So we can make a ratio of that. I usually put my first word in the numerator, so reading to math. So I'm going to make a ratio of reading to math is 3 to 5. So we can make a ratio of reading to math 3 to 5. The 3 goes with the first word of reading, 5 goes with the second word of math. Okay? The instructions say list all possible ratios. So we can make a ratio of reading to math. We can also make a ratio of reading to the total students. So if reading to math is 3 to 5, if there's 3 who like best of reading and 5 who like math the best, then there's a total of 8. 3 plus 5 is 8. So the reading, people who liked reading was 3, but then there's a total of 8 students. Then you can do a ratio of math to the total, and math was 5, and then the total is 8. Okay, now we need to look at what the rest of the problem gives us to be able to solve it. Okay, because then we can use one of these ratios to help solve the problem. Some of the given information is the class has a total of 24 students, and they want to know how many like math the best. So we were given total students was 24, and what we want to know is how many like math. So since we are given a total and we're wanting to know math, then you come over here to the ratio that deals with total and math. So the one that deals with total and math is this one, math and total. Okay, so this is the ratio that we're going to use to help solve this problem. Okay, so we had a ratio of 5 people like math the best out of 8. So that's our math to total, and then you always put, okay, if we're going to use math and total, then we're using M and total over here on this side as well. Because the idea on all of these problems is to set up a fraction set equal to a fraction. We're going to have a ratio equal to a ratio to help us solve. So over here we have math to total, so over here we have math to total as well. So M is what we're trying to find. We don't know how many like math the best, but we do know out of the total class is 24 students. So if we have a ratio of 5 to 8, how many will like math when there is a total number of students of 24? That's what we're looking for. So whenever you have a fraction set equal to a fraction, the way we can solve that is cross multiply. Okay? When you cross multiply, anytime you have a fraction set equal to a fraction, you can cross multiply. So here we can say 5 times 24 on one side of the equal sign equals 8 times M. Okay, then you can see you can divide both sides by 8 to solve for M. So then M is going to equal, when you do 5 times 24 and then divide it by 8, let's see, let me do 5 times 24. That will be 120 divided by 8. And so then M equals 15. So when there is a total students, a class of 24 students, 15 of them will like math the best. And that's how that works. Alright, let's look at 16B4. Okay, you're told that a chosen color was 3 parts forest green to 1 part antique ivory. Okay, I can go ahead and make a ratio right now of that. So it's 3 parts forest green. So I'm just going to use F for forest green over A for antique ivory. Okay? So that ratio is 3 parts forest green to 1 part antique ivory. So we can make 2 other ratios with this information. So, because we can do a ratio of forest green to antique ivory, we can do a ratio of forest green to the total, and we can do a ratio of antique to the total parts. So if we did forest to the total, forest was 3 parts. The total is adding these 2 numbers together. So we have 3 parts of forest to a total of 4. And then to do antique to the total, our antique was 1 part. And then the total would be, again, adding these 2 numbers together, 4. Now let's go back and look at what the problem is asking. Julia needs 8 gallons of paint. How many quarts of each color should she buy? Okay. Well, I can first see that gallons and quarts is not the same unit. So therefore, I know at some point I'm going to have to do some sort of unit conversion. So if I know she needs 8 gallons, that's the total number of paint that she needs. Okay? So I was given, in part of my information, I was given the total paint. Okay? Total paint was 8 gallons. And what it's asking, our question mark, what they're asking is, how many, let's just say many, how many of each color? So basically, I'm just going to start with how many of forest green. So if I want to know how much forest green, and yet I've been given a total, then I come over here to my ratio that deals with forest green and total. This ratio right here deals with forest green and total. This one is forest green and antique ivory. This one is antique ivory and total. This is the only one that's forest green and total. So this is the ratio that I want to use to help solve the problem. Okay? So to solve the problem, we're basically going to say forest over total, and we're going to set it equal to another ratio that's the forest green over total. But this ratio comes from right here, 3 over 4. Then this ratio comes from the other information that was given. We want to know how much forest green does she need. That's what I don't know, so I leave that as an F. And then this was the total gallons, or the total that she needed, which was 8 gallons. So basically what we're saying is, when the ratio is 3 to 4, how much will she need of F when she has 8 gallons? Okay? Anytime you have a fraction set equal to a fraction, then you cross multiply to solve it. We're going to turn this into quarts here in a minute. So to cross multiply, we're saying 3 times 8. So 3 times our 8 gallons equals 4 times F. So basically 24 gallons equals 4F. Divide both sides by 4. So F equals 6 gallons. So the amount we need for forest green is 6 gallons, but they're asking in quarts. There are 4 quarts to a gallon. So if we multiply 4 quarts to 1 gallon, basically our gallons go away and we end up with 24 quarts. Okay, that's how much of the forest green that we need. But the problem is also asking how much of the antique ivory do we need? Well, if we knew that there was a total of 8 gallons to begin with, and 6 of those gallons were forest green, then we know that 2 of those gallons is antique ivory. So we know that antique ivory is 2 gallons, because I did 8 gallons minus 6 gallons. But I need to turn that into quarts. So to turn it into quarts, you multiply it by 4, because there are 4 quarts in a gallon. Gallons cancel. And so for the antique ivory, you end up with 8 quarts. Alright, we're looking at 16B3. Okay, the ratio that Mary spends on sports to schoolwork is 2 to 3. Okay, I'm just going to stop right there and see what information I can write down. So we can write a ratio of what she spends on sports to schoolwork. I'm just going to do SP sports to schoolwork. Okay? The problem tells me she spends 2 to 3, for every 2 hours she spends on sports, she spends 3 hours on school. So the ratio is 2 to 3 that she does for sports and school. Okay? So I can also write a ratio of sports to the total. If you're getting the pattern, you can always do the first one to the total, then the second one to the total. Okay? Sports to the total. So sports is 2. The total hours, adding those two together, 5. Then we can write a ratio of school to the total. So school is 3. The total is still 5. The total doesn't change. The total should always stay the same. Now let's go look at the problem. What they give in the given, it says she spends 4 hours on sports. Okay, it's practicing sports. Then what do we want to know? The question is, how many hours on school? Hours on school. So since this is the rest of the problem, sports and school, we need to find a ratio over here that we can use to solve the problem. Okay, so we look over here and find a ratio that deals with sports and school, since this is the information given and this is the information we want to know. So looking over here, this is the only ratio that deals with sports and school. So we're going to use that ratio to set up our equation. So we can set up a ratio of sports over school, set it equal to another ratio of sports over school. If you put sports in the numerator here, put sports in the numerator here. So sports over school, we have this ratio right here of 2 over 3. Then over here, the information that they tell us is she spends 4 hours on sports. So we can put a 4 here on sports because that's what sports is. Sports is in the numerator here, so sports is in the numerator here. Then how many hours on school? We don't know, so that should be our unknown. In all of these equations of setting a fraction equal to a fraction, there should be one unknown. Now we can solve this. When you have a fraction set equal to a fraction, you can solve it by cross multiplication. So 2 times schoolwork equals 3 times 4, which is 12. Divide both sides by 2. And now the amount of time she spends on schoolwork is 6 hours. And that's what they're asking. Okay, I'm going to do practice on percentages. In lesson 14, we did percentage problems. And so I'm going to do a couple of the percentage problems out of this lesson. We're looking at 16D12. You're told that before the battle there was a total of 1,650 Marines. After the battle, 932 Marines remained. So number 12 is asking, what's the percentage of the Marines who remained? So don't forget, when you're doing a percentage, percentage equals the part over the total, and then you multiply that by 100 to get a percentage. Okay? So to get the percent of the Marines who remained, we want the part over the total. So the ones who remained were 932 over, we want to do over the total Marines. The total Marines, we were told, were 1,650. So dividing that out, 932 divided by 1650 is 0.6565. I rounded, but you don't leave your percentage in a decimal. You multiply it by 100 to get a percentage, and that comes out to 56.5%. That is the percent of the Marines who remained. So 932 of 1650 is 56.5%. Now they want to know what is the percent of the Marines who are killed. Okay, well, if 932 Marines remained, where they were left after the battle, then how many were killed? Well, we can take 1650 minus 932, and that will tell you how many were killed. So, let's see. That would be 718 were killed. So to find the percentage, we do the part over the total, so which is 718 out of the total Marines. We can get a decimal for that. 0.435, but you don't leave it a decimal. You multiply by 100 to turn it into a percentage, and that would be 43.5% of the Marines were killed. And what do you notice about these two numbers? So those two numbers should add up to 100%, because if 56.5% remained, that means the other 43.5% were killed. These two numbers should add up to 100.